Hello everyone, this is Dr. Savitha M. I am uh, discussing on environment pollution and water chemistry. This is my video on the estimation of um, sulfur and fluoride using gravimetry and colorimetry. Okay, so all these will be uploaded in the YouTube channel, My Intuition. Kindly refer the videos there. Okay, next first let me discuss on estimation of sulfates. Okay, now the sources of sulfate in water. Leaching from the sulfur deposits on earth result in sulfur contamination in water bodies. The limit of sulfate in drinking water is up to 250 milligrams per liter. Okay, then estimation of sulfur can be done by gravimetry method. Now what is gravimetry method? Okay, gravimetric process is the sulfate present in the water will be made to get precipitated out, and then how much precipitate is formed, that is equal to the amount of sulfate present. Okay, the first thing is we need to precipitate out the sulfate. For this we will be using barium ions. Okay, sulfate present in the water will react with excess barium ions under acidic condition and gets precipitated as barium sulfate. Okay, now this barium sulfate is washed and dried at around 130 degrees, and then the weight of barium sulfate is used for the calculation of or finding estimation of the sulfate present. Okay, now the sulfate present in the water will be precipitated out as barium sulfate. For this, a known volume of water sample containing sulfate is taken in a beaker and it is boiled. Okay, to the hot solution only, barium chloride solution is added drop by drop until all the barium sulfate precipitates out. The precipitate is then precipitate itself is barium sulfate. The precipitate is then separated from the solution using a funnel. That means by filtering through a Wattman filter paper. Then the Wattman filter paper containing the precipitate is placed in a previously weighed silica crucible. Okay, then the crucible is kept in a burner and it is burned completely until it removes all the water content, and the filter paper also burns out, and only the precipitate remaining will be barium sulfate, right? So we have to keep burning until the what crucible gives uniform weight. Okay, next by calculation we can find out the amount of sulfates present. See, weight of barium sulfate, W2 minus W1. W2 is the weight of the crucible with the precipitate. Then W1 is the weight of only the crucible. Before burning itself, we will be taking the empty weight. That will give you the weight of the sample. Okay, now see, you can see if you write the reaction barium plus sulfate, you will get barium sulfate. That means 1 mole of sulfate will produce 1 mole of barium sulfate. So one molecule ion will give 1 molecule of barium sulfate. Okay, that, or in other words we can tell 1 mole of barium sulfate contains 1 mole of sulfate. Okay, one and the same. If you see the molecular weight of barium sulfate, it is 233.3 grams. Therefore, 233.3 grams of barium sulfate contains 96 grams of sulfate. Sulfur is 32, oxygen oxide is 16. If you add all this, you will get 96. Okay, therefore it means that 233.3 grams of barium sulfate contains 96 grams of sulfate. Okay, how much will 1 gram of barium sulfate contain? 1 gram contains 96 divided by 233.3 grams of sulfate, right? Now that means if you take 1 gram of barium sulfate, it contains 96 by 233.3 grams of sulfate, but we have got W weight of barium sulfate. So if 1 gram of barium sulfate contains so much, W gram contains how much? Okay, so you will get 96 by 233.3 into W. That means V volume of water sample containing so much amount of sulfate. Okay, therefore, if VML contains so much of sulphate, how much will 1 liter contain? Right? That means you have to multiply this by 100, I mean 1000. Okay, therefore, the amount of sulphate in milligrams per liter will be 96 by 233.3 into W by V, milligrams per liter. Okay, so this is the amount of sulphate present in the water sample given. Next is fluoride, estimation of fluoride. Okay, then natural sources of fluoride is the natural deposit, coke, glass, all these are the pesticides, fertilizer industry, steel and aluminum processing industries, all these are the sources of fluoride. Okay, sources of fluoride liberation to the water bodies. Okay, now why fluoride is I mean, estimation is important because the fluoride concentration of approximately 1 milligrams per liter in drinking water is recommended. Okay, beyond that is not good. Higher concentration, that is above 4 milligrams, causes dental fluorosis. Lower concentration is also not advisable because it causes dental caries. Okay, so then the concentration of fluoride can be estimated by colorimetry. Colorimetry is a experimental method for the estimation of fluoride. Here we will be using zirconium SPADNS complex. Okay, now the principle here is the zirconium SPADNS complex is a reagent. Okay, for this if you add this reagent to the water sample containing fluorides, then this fluoride will dissociate this complex into two separate. That means this zirconium will react with the fluoride and SPADNS will be liberated. Okay, it will dissociate the colored complex. This is a colored complex into a colorless SPADNS complex and zirconium fluoride, hexafluoride. Okay, which is now how much this complex is formed, zirconium fluoride, hexafluoride complex is formed, that depends upon the amount of fluoride. Okay, see here you can see the reaction. Fluoride is present in the water sample. This is the reagent we are adding and it is crimson red in color. Now if at all fluoride is present, then the fluoride will pull out the zirconium and this SPADNS will be released, which is colorless. Okay, now how to find out the process, experimental process. Okay, you need to make 5 different concentration standard solutions from 0.2 to 1.5 milligrams per liter. Different standard calibration. For calibration graph you need to prepare different fluoride solution. Okay, next I mean by using potassium fluoride, the salt. Okay, next uh, to all these flask some fixed volume of this reagent is added. If you add 5 ml for one flask, for all the flask you need to add 5 ml. Okay, now lower fluoride concentration will be a less intense color in color because a less amount of fluoride is present, and the more intense colored will be the more concentrated solution. Okay, now keeping in an colorimeter, setting the lambda max into 570 nanometers, we have to find out the absorbance of all the standard solutions. Okay, then using a standard plot, what we can do is by taking fluoride concentration along the x-axis and the absorbance along the y-axis, we can find out the volume of the uh, sample present, fluoride sample present. Okay, next by using the formula, this formula, absorbance of the sample we can find out from the colorimeter. Now what standard we are choosing, concentrated of that standard into 1000 divided by absorbance of the standard and volume of the sample taken. Okay, by this we can find out the fluoride concentration. Okay, this is the estimation of sulphate by gravimetry method and the estimation of fluoride by colorimetry method. Okay, so that will discuss is being discussed in this video. Next I shall be going for the next topic.